Alright, this video is going to be over naming and writing formulas for molecular compounds, and then at the end we're going to mix up some of the stuff that we've been doing for the past couple of weeks in class. Alright, so first, and if you are taking notes for the first time over this, you might want to pause the video and write this stuff down and then go back in and fill it in as we fill it in the video. Alright, so in this table, I'm going to make it a little bit bigger. Alright, we're given a molecular formula over here, and then we're given the name of the compound right here. And it says that we're going to put the number of atoms of the first element in this block and the number of atoms of the second element in this block. So in this first one, for ClF, there are the first element is chlorine, and we've got one of them. And then the second element is fluorine, and we've got one of those. Okay? And then in the second row, we've got chlorine as the first element, and there's 1 and 5 fluorines. And the third one, there's 1 carbon and 1 oxygen. And in the second one, or the fourth one, I'm sorry, there's 1 carbon, 2 oxygen. And then next, we've got 2 chlorines and 1 oxygen. And then next, we've got 1 phosphorus and 5 chlorines. And then after that, we've got 2 nitrogens and 5 oxygens. So keep this in mind while we go through what's going on here. But the first thing that I want to make note of is that we've got, that I want to make note of, I'm sorry, blanked out, is that all of these here, chlorine and fluorine, carbon and oxygen, chlorine and oxygen, phosphorus, chlorine and nitrogen and oxygen, they're all nonmetals. Right, they're all on the right side of the jagged line on the periodic table. And not only that, but if they're all nonmetals, what kind of bonds have to form between those elements? They're covalent bonds. And so if it's all covalent bonds, then we call these molecular compounds. Okay, so all of these are called molecular compounds. All right, and if we draw our attention to these two compounds right here, they're both made with chlorines and fluorines, so why couldn't we just call this chlorine fluoride? We couldn't call it chlorine fluoride because they're two different compounds and they would be named the same thing. The difference between covalent compounds and ionic compounds, when we have covalent compounds, they form because they're trying to complete each other's octet, while ionic compounds are just forming to balance out their charges. So I'm going to write that down. I'm going to make this smaller up here and say covalent compounds or molecular compounds. So covalent bonds form to complete the outer valence electrons or octet. While ionic bonds balance opposite charges. Okay, so with covalent bonds and molecular compounds, you can have a varying number of arrangements. So you can have CLF, you can have CLF 4 or CLF5, and so all these different compounds exist, whereas if you have sodium bromide, it has to be NaBr because Na is +1 and Br is -1, so the only thing you can have is NaBr. That's the only thing possible for the ionic compound. But covalent compounds or molecular compounds, they have varying, many different arrangements. So we have to use something different in order to designate different names for each one of these different formulas. All right, so here's some examples. We have BCl3, which is boron trichloride, SF6, which is sulfur hexafluoride, IF7, which is iodine heptafluoride, and then nitrogen triiodide, dinitrogen tetraoxide, dinitrogen monoxide, tetraphosphorus decoxide, pentaboron nonanhydride, tribromine octoxide, and chlorine monofluoride. And so if we see all of those examples, we start to see the trend here. So in these molecular compounds, we're using prefixes. And specifically, we're using prefixes always on the second element and some of the time on the first element. So when are we not using prefixes in these molecular compounds? Yeah, we're not using prefixes when you have one of the first elements. So for example, whenever we have boron trichloride, sulfur hexafluoride, iodine, nitrogen, and then we're using prefixes on this one, this one, this one, this one, this one, and all of the second ones. So the only time you don't use a prefix is when you've got one of the first element. So no prefix when only one of the first element. And if we go through and we try to figure out what prefixes go to what we find is that mono means 1, and di means 2, tri is 3, tetra is 4, 5 for penta, 6 for hexa, 7 for hepta, 8 for octa, 9 for nona, and 10 for deca. And so most of these you should be pretty familiar with. If you're not, you need to make sure that you memorize those prefixes. Also, I'd like to make a note of the ending of each one of these. The ending of the first element doesn't change. If you see here, boron is just boron, sulfur is just sulfur is just sulfur, iodine is just iodine, nitrogen, dinitrogen, tetraphosphorus, none of those changed. But in the second element, they all changed to end with "ide." So you always need to change the ending to "ide." Second, or the last thing is spelling. So if you look here at tetraoxide versus tetraphosphorus, and I just noticed a mistake here. This tetraoxide is actually spelled incorrectly. It should read tetra or tetroxide. Okay, and so if we see that, and then we see tetraphosphorus oxide down here, you can see the A is still here for tetra, but the A disappears here next to oxide. And we see it again with monoxide, decoxide, octoxide, So we get rid of that last vowel and we replace it with the O from oxide for all of those. The only one that doesn't happen with is tri, so you would still write trioxide. And this one is triiodide, so you still keep the I's there. All right, and a lot of that just comes from seeing it over and over again, and you'll get used to that. All right, so let's try some examples here of writing the name of the molecule from the formula. And so these are all going to be molecular compounds. So we have one phosphorus, and since it's the first element, we don't have to put a prefix on it. So it's just going to be phosphorus. And then we've got 3 bromines, and so that's going to be tribromide. All right, and then next we have SCl4, and so we've only got one of the first element, so there's no need for a prefix, so it's going to be sulfur. And then we have 4 chlorines, so the prefix for 4 is tetra, so it's going to be tetrachloride. And then next we have 2 nitrogens for the first element, and so we still have to use the prefix for that, so it's going to be dinitrogen, and the ending doesn't change on nitrogen, and then difluoride. Okay, next we have SO3, and so that's going to be sulfur trioxide. All right, after that we have bromine monofluoride. You can't forget the mono on the second one if there's only one of the second element. All right, and then to write some formulas from the names, di is the prefix for 2, and so there's 2 sulfurs, and then deca is the prefix for 10, and so it's S2F10. And then next we have carbon, and since there's no prefix, that means we only have one of them. And then we have 4 chlorides. All right. Oxygen, we only have one because there's no prefix. And then we have di, so that means 2 fluorides, or fluorines. After that is 2 nitrogens and 3 oxygens, and then we have 4 phosphorus and 7 sulfurs. All right, so up here I have an example box where we're looking at chemical formulas, and we're discussing what type of compound it is, what kind of type of bonding is taking place, and then the name of the compound. So remember, if it's a metal and a nonmetal, it's going to be ionic, and if it's 2 nonmetals, then it's going to be molecular. All right, so let's do some of these together. All right, so first we have CS2, and since those are both non-metals, that means that this is going to be a molecular compound or covalent bonding. And then the compound name, since it's molecular, we have to use prefixes. So it's going to be carbon disulfide. All right, and then next we have PbI2, and Pb is a metal, so that's going to be ionic. And since this is a special type of ionic, we don't know the charge of lead by looking at the periodic table. We have to use Roman numerals on this. So bringing up these charges again, we would get Pb2 plus and I minus. And so lead has a negative, or has a positive 2 charge, so the name of this is going to be lead 2 iodide. All right, next is barium chloride, and barium chloride, barium is a metal, and so this is ionic. And then there's nothing special about this. We don't care about the charges, we don't care about anything, we just name it. So we name the cation, then the anion, and so this is just going to be barium chloride. All right, and next is Se2S6, and that is, they're all nonmetals, so it's molecular. Okay, and so with molecular compounds, we have to use prefixes. And so the prefix for selenium is di, because there's 2 of them, so that's diselenium. And then hexasulfide, because there's 6 sulfurs. All right, so now we have some names, and we have to go backwards. So we have Xenon Tetrafluoride. That's going to be molecular. And there's 2 ways that I know that. 1, because I'm using prefixes, and 2, because xenon and fluorine are both nonmetals. And so if I have to write the formula for this, we've only got 1 xenon because it doesn't have a prefix, and there's 4 fluorines. So it's going to be XeF4. All right, next is sodium phosphide, and sodium is a metal, and so this is ionic. And since this is an ionic and we have to write the formulas, you have to write the anions, or write the ions down, so that you can balance the charges. And so if I write these ions down, I would have sodium is +1 and phosphide is -3. So if I balance that out, I have to have 3 pluses for every single one of these, because it's 3 negative, and so if I have 3 sodiums, that would give me 3 pluses, and so it's going to be Na3P. All right, and then next we have dinitrogen pentoxide, and so this again is molecular, because you see the prefixes, and so di is for 2, and pent is for 5. And so that's going to be N2O5. You don't have to do any switching or anything crazy like that. It's just straight up what it says. And then the last one is Cobalt-2 bromide, and that's going to be ionic because cobalt is a metal. And so we have to write the ions for this. And so Cobalt-2, I'm sorry, it's going to have a 2+ charge, and bromide is -1. And so when we write the formula for this, we would have COBr2. All right, so that's all I've got for this. You can get very confused. You'll get it one day, and then the next you'll forget it if you don't practice enough, so keep practicing. If I were you, I'd make some index cards with some of these compounds mixed up in there and having to give the names and having to give the formulas. Simply because it will make you realize what type of naming you have to use. So whether or not you have to use Roman numerals or prefixes, or if you just have to name it, you'll get used to having to do that. And the faster you can get at this, the better.